It is considered the frosty home of countless comets and minor planets, and yet astronomers have only just begun to uncover the hidden secrets of the remote Kuiper belt. In fact, the existence of this cosmic ring of icy chunks was only proven in 1992, and it even seems possible that a large, completely unknown planet is still hiding out there. To get to the bottom of the Kuiper belt, the James Webb telescope recently turned its attention to the remote extreme zone and discovered something sensational. Some of the celestial bodies there could actually radiate heat and thus even harbor life. The remote outer region of the solar system still holds countless blank spots on star maps. For a long time, the only thing we knew about this remote area was that the origin of the comets must lie dormant somewhere out there. After all, the trajectory of these galactic chunks extends far beyond the orbit of Neptune. However, the details of what kind of formations are out there and whether there are any celestial bodies at all remained an unsolved mystery for a long time. One of the first to approach the mystery surrounding the source of the comets was Jan Hendrik Oort. In 1950, the Dutch astronomer put forward a model based on a bowl-shaped zone at the outermost edge of the solar system, which also serves as a natural reservoir for comet nuclei. Every time the cloud is influenced by the gravity of interstellar gas clouds or neighboring stars, some chunks are thrown out of their orbit and become periodic comets. So much for the theory, but the bottom line is that Oort's explanations were only able to explain the orbits of long-period comets, which have a rather random distribution and are sometimes strongly inclined to the planetary orbits. However, the Oort cloud could not explain the characteristics of short-period comets, such as Halley's Comet. In view of this, astronomer Gerard Kuiper came to the conclusion in 1951 that there must be a second comet reservoir out there, somewhat closer to the Sun. This would take the form of a gigantic ring of icy debris just beyond the orbits of Neptune and Pluto. On paper, Kuiper had thus provided a plausible solution to the problem that had caused Oort's model to fail. Shortly before, in practice, however, the new approach also had a huge catch because it could not be proven for decades. At the time, there was simply no telescope capable of detecting smaller celestial objects at such gigantic distances. It would ultimately take until 1992 before Kuiper's assumptions were realized. With the help of the Mauna Kea Observatory in Hawaii, astronomers Jane Liu and David Jewett spent 5 years searching for telltale traces in space and finally identified the first trans-Neptunian object from the Kuiper belt with the faint light spot 15,760 Albion. The Kuiper belt, hiding an unknown planet, is today known to extend for about 30 to 50 astronomical units beyond the orbit of Neptune. A brief reminder, the length of an astronomical unit corresponds to the average distance between the Earth and the Sun, or in other words, around 150 million kilometers. In its foothills, the Kuiper belt gradually merges into the inner edge of the Oort cloud. The frosty reservoir would therefore be around 20 times larger than the asteroid belt between Mars and Jupiter and up to 200 times more massive. But what does the situation actually look like in the heart of the Kuiper belt? Experts believe that there are over 70,000 objects with a diameter of more than 100 kilometers in this area, but smaller bodies are invisible even to powerful space telescopes such as Hubble due to the enormous distance. In fact, it took until 2019 before a team of researchers succeeded for the first time in detecting a Kuiper belt object with a diameter of less than 10 kilometers. At the same time, the 1.6 kilometers lump provided proof that smaller bodies also exist there. Nevertheless, we are still a long way from knowing how many objects the Kuiper belt really contains. What we do know, however, is that it is home to several dwarf planets, which ultimately cost Pluto its official planetary status. After more and more Plutoids, or in other words, similarly sized bodies, were found in the Kuiper belt, the International Astronomical Union decided to redefine the term planet in 2006. Since then, Pluto has been listed in the newly opened ranks of dwarf planets. But who knows, another celestial body in the Kuiper belt may soon be included in a slightly older category. In fact, the signs that another undiscovered planetary world is slumbering in the outer reaches of the solar system seem to be growing ever stronger. The first indications of the hypothetical Planet 9 were provided in 2015 by the orbits of 6 larger objects in the scattered area of the Kuiper belt. In detail, experts recognize that dwarf planets such as Sedna describe eccentric, highly elliptical orbits whose main axis lies in the same direction. In addition, their orbit is also inclined by around 30 degrees to the ecliptic, or in other words, to the apparent orbit of the Sun. Following this discovery, astronomers were then able to identify other Kuiper belt objects with very similar characteristics. But what is it all about? Can it really just be a coincidence? Well, if Mike Brown from the California Institute of Technology has his way, we have the answer to this question with a definite no. If we follow the astronomers' explanations, the probability of a coincidence is just 0.7%. Instead, the similarities of the orbits would suggest the urgent conclusion that the observed celestial bodies are influenced by the gravitational force of one or more objects. In search of Planet 9, what is responsible for the gravitational effect? Well, at first glance, you might assume that the Kuiper belt objects influence each other. At second glance, however, you realize that the zone would have to be 100 times more massive than generally assumed. An alternative approach is based on the existence of a ring structure consisting of many smaller chunks whose combined gravity is the cause of the orbital anomalies observed in Sedna and company. Indeed, this hypothesis should also stand up to scrutiny in the context of a model, although the Kuiper belt would also have to harbor significantly more objects than conventional wisdom says. Finally, the third and by far most exciting explanation is based on the influence of a previously undiscovered planet in the Kuiper belt. According to the model calculations, Planet 9 would have about 10 Earth masses and a diameter slightly smaller than that of Neptune. Furthermore, the theory states that it orbits at a distance of between 4,500 astronomical units. In other words, Planet 9 is on average 20 times further away from the Sun than Neptune, and it takes a whopping 15,000 years to complete a full orbit. According to Brown, the chances of Planet 9 being real are anything but bad. He puts the corresponding probability at more than 90%. But how is it then that Planet 9 has so far simply failed to rise above the status of a hypothetical celestial body? After all, mankind has been looking up at the night sky for thousands of years, and the following shows that our ancestors were extremely successful in doing so. Since ancient times, only 2 new planets have been detected in the solar system. According to the researchers, the fact that Planet 9 is not yet one of them could be due to the fact that it's currently in the furthest part of its own orbit from the Sun. As a result, it would appear invisible even to the most powerful telescopes. Furthermore, model calculations have shown that the intrinsic luminosity of Planet 9 could be as low as 0.006. For comparison, Neptune has a value of 0.01 in this category. And then there is the radiation problem. The main radiation emitted by Planet 9 could be predominantly in the infrared range. As a result, the planet's temperature would have to be around 47 K, or minus 226 degrees Celsius. It would therefore only be a good 35 degrees warmer than its galactic surroundings. Against this background, Planet 9 would therefore be best detected in the far infrared range. But whether and when we will add another member to the list of planets is still written in the stars. Not in the stars, but in the astronomical headlines. What the James Webb telescope recently discovered in the Kuiper belt is not only suspected of hiding an unknown planet, but also extraterrestrial life. A spectacular discovery. At first, one would probably assume that the Kuiper belt is a cosmic no man's land, an icy area that only harbors dead objects. Given the extreme conditions that prevail here, the thought of the existence of liquid water or even living beings seems simply inconceivable. But now, the James Webb telescope has gathered new data that fundamentally challenges this assumption. The study, which was carried out by Christopher Glaine's team from the Southwest Research Institute, focused on the 2 dwarf planets Eris and Makemake. As part of their work, the experts finally came across frozen methane that had only recently been cooked. In other words, the discovery indicates that there are hot cores at the heart of the frosty dwarf planets that are capable of transporting liquids and gases to the surface. But that's not all. According to Glaine, the relatively young methane deposits also suggest that the dwarf planets could harbor subglacial oceans. Icy moons such as Europa have already proven that many a celestial body in the solar system hides a sloshing secret, and if this researcher has his way, the hot cores could also point to sources of liquid water beneath the icy surfaces. It's even conceivable that some of these frozen dwarf planet worlds offer conditions that are conducive to life. At the moment, however, this is still a purely theoretical assumption, and in order to test its correctness, a direct venture into these frontiers seems extremely promising. After all, NASA's New Horizons mission to Pluto and beyond has already uncovered a complex world with a diverse topography. Since then, we have known that the Kuiper belt is sometimes much more dynamic than previously assumed. In order to put the exciting Webb data into a geological context, Glane hopes that the renowned space agency will send another probe into the Kuiper belt in the foreseeable future. According to the expert himself, he is certain that we will be absolutely astounded by the wonders that await us there, and so that we can also regularly amaze you with the wonders of space. The Kuiper belt, often likened to the asteroid belt's more distant cousin, remains one of the least understood regions of our solar system. This vast, ring-shaped zone is populated with a diverse array of icy bodies, some of which are remnants from the early solar system. Beyond its significance in understanding the formation and evolution of planetary bodies, the Kuiper belt also holds clues to the dynamic processes that shaped the outer regions of our solar system. It is not just a repository of ancient ice. It also provides a window into the past, revealing the conditions that prevailed during the early epochs of planetary formation. One of the most intriguing aspects of the Kuiper belt is its potential for uncovering the origins of the solar system's architecture. The distribution and characteristics of Kuiper belt objects, KBOs, offer insights into the gravitational influences that have sculpted the solar system. For instance, the orbit of some KBOs shows significant perturbations that suggest interactions with massive bodies, possibly even those beyond the current observational reach. These gravitational interactions could have been influenced by the migration of giant planets like Neptune, which might have shifted the orbits of these icy bodies as it moved outward from the Sun. In addition to its role in understanding solar system dynamics, the Kuiper belt has become a focal point for searching for traces of early solar system materials. The icy bodies within the Kuiper belt are believed to be relatively unchanged since the formation of the solar system, making them time capsules that contain primordial materials. Analyzing these objects can reveal information about the early chemical environment of the solar system, including the presence of complex organic molecules that might have been precursors to life. Recent observations suggest that some KBOs contain not just simple ices but also complex organic compounds, adding an extra layer of intrigue to their study. The discovery of Eris and Haumea, two significant dwarf planets in the Kuiper belt, has further enriched our understanding of this region. Eris, which is slightly smaller than Pluto but more massive, was discovered in 2005 and has a highly inclined orbit. Its discovery led to the reclassification of Pluto, sparking a debate within the astronomical community about what constitutes a planet. Haumea, with its elongated shape due to its rapid rotation, reveals the diverse forms and physical characteristics of Kuiper belt objects. These findings underscore the complexity and variety of the bodies residing in the Kuiper belt. Another key discovery in recent years has been the detection of binary systems among KBOs. These systems, where two objects orbit a common center of mass, offer insights into the formation and evolutionary processes of Kuiper belt objects. For example, the binary system of Pluto and Charon, which was discovered in 1978, has provided valuable data about the size, mass, and orbital characteristics of these bodies. Similar discoveries in the Kuiper belt, such as the binary system of Haumea and its moon Hyakka, further highlight the dynamic interactions within this distant region. The search for Planet 9, which has been hypothesized to be a massive, undiscovered planet affecting the orbits of distant KBOs, continues to drive exploration and observational efforts. If Planet 9 exists, it could be an intriguing remnant from the early solar system or a later addition. The gravitational influence of such a planet could shed light on the processes that have shaped the solar system's outer boundaries. Observations are ongoing, with astronomers using a variety of methods to detect this elusive planet, including deep surveys of the sky and advanced computer models to predict its location and characteristics. The exploration of the Kuiper belt also involves international collaboration, with missions planned by various space agencies and research institutions. NASA's New Horizons mission, which provided the first close-up images of Pluto and its moons, has set a precedent for future missions to the Kuiper belt. Upcoming missions, such as those proposed by the European Space Agency and other international partners, aim to further investigate this distant region, potentially sending spacecraft to study additional KBOs and gather more detailed data about their composition and behavior. Moreover, the study of the Kuiper belt extends beyond our solar system's boundaries. Similar structures, known as debris disks, have been observed around other stars, offering a comparative perspective on how planetary systems evolve. By studying these distant systems, astronomers can gain insights into the formation of planetary belts and the potential for habitable environments around other stars. This comparative approach helps to contextualize our understanding of the Kuiper belt within a broader framework of stellar and planetary formation. The ongoing research into the Kuiper belt is not just about uncovering the secrets of our solar system. It is also about understanding the broader processes that govern planetary formation and evolution. The insights gained from studying this distant region can inform our knowledge of other planetary systems and contribute to the search for extraterrestrial life. As technology advances and observational techniques improve, the mysteries of the Kuiper belt will continue to unfold, revealing new aspects of our cosmic neighborhood and the fundamental processes that shape the universe. In conclusion, the Kuiper belt is a treasure trove of scientific opportunities, offering valuable clues about the early solar system and the processes that govern planetary formation. The ongoing exploration of this distant region, driven by advanced telescopes and space missions, promises to yield exciting discoveries and deepen our understanding of the outer solar system. As researchers continue to probe the mysteries of the Kuiper belt, we stand on the brink of uncovering new and transformative knowledge about our place in the cosmos.